So rolling, recording check 1, 2. Okay, it's just after 9 o'clock. Good morning, Cisco cohort. Welcome to the last sync session for this class. And let's go over what's happening here for the remainder of the semester, or in the next to the last week of the semester. Today I'm going to cover the lab 10.8.2 that I switched up to you on the last minute. I'll pull that up in a second and show you where to find that. It's going to cover the Cisco Discovery Protocol, the Link Layer Discovery Protocol, and the Network Time Protocol. Then Monday, that would be the day that if we were still coming to school, we would have our practical exam, our lab skills exam. And we're not having that this semester due to the Rona, so you guys are relieved of that. So Monday, I've set aside as a work day. There'll be no sync session. Today's our last sync session. And if you could go in and take the course feedback form at your convenience sometime before Wednesday, the day of the final exam, because Cisco has a business rule that that course feedback form, which is a student satisfaction survey, must be taken sometime before you take the final exam. This is completely separate and different from the Web Advisor one that we asked you guys to take a week or two ago. And then a week from today is our scheduled final exam. If we were still in school, coming to school, the exam would be administered from 9:30 to 11:30 in the morning, and we're supposed to give you 2 hours, and the exam is 1 hour and 45 minutes. But the deans have asked us to spread this all out since some people may have trouble logging in and so forth. So I'm going to turn, it should be turned on at 9:30 a.m. in the morning. I'm probably going to turn it on a week from today around 9 a.m. in the morning. And that final exam is found in the assignments portion of the Cisco Netacad site. I've also turned on the practice final exam, and the practice final exam has got a cool feature that won't be here much longer because Cisco is moving to secured exams. On the other class that I teach with another curriculum, it's already secured exam. But here's what you can do as a practice for the final exam. And I've got this already turned on. I'll turn it off sometime before Wednesday so you don't confuse it with the real exam. You can go into your assignments portion of the Cisco Netacad site and take the final exam. And here's what you can do. You can just take, excuse me, you can take like 1 or 2 questions and just, it doesn't matter what you answer. And then tell it to submit the test. And he's going to complain like crazy and say, oh, you haven't answered all the 55 questions or whatever it is. And then you'll be able to, after you've submitted it, it'll offer you something called course feedback and item feedback. Course feedback, don't use that. That's pretty useless. But the one that says item feedback will show you all the questions and answers and give you sort of a practice thing for the final exam. So that final exam will be Wednesday, and you can take that probably about 9 a.m. or so. I'll have that test turned on. You can take it anytime within the pretty much the next 24 hours after that time. And then Thursday about 9 a.m., final deadline for our work. I'm going to deactivate all exams. Hey, Liz, I'm just checking attendance. 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8. I'm missing something. Am I missing here? Got him. Oh, I got it. I got it. Now we're caught up. Okay. Okay, so Thursday night, I have to turn off all exams and submit the grades to the dean because it's a venial sin for faculty to turn their grades in late. Or is that a mortal sin? I need Catholics up there. What's the difference between a venial sin and a mortal sin? Okay, so I'm going to, enough joviality and humor here, and let's go to, I want to show you where this lab is because I switched you guys up at the last minute, so there might be some confusion here. I'm going to share the my TCC Blackboard student lab printouts page. And the lab that we're going to do is the 10.8.2 lab, which is, most of it works in Packet Tracer. There's a command show CDP traffic that doesn't work. I'm going to step through this whole lab for you guys today. It's a PDF file. If you don't have the ability to edit PDF files, what you can do is simply create a Notepad file or a WordPad file or a Microsoft Word document, and you can put your answers in there to the questions. There's a few questions in there that should be answered, and you can submit that to me to get your lab credit for that particular lab. So that's that particular lab, and let me show you what it actually looks like here. That's the lab we're going to step through today. So it's the reason I did this instead of the old lab that was originally scheduled there was the old lab had, it had a weird cloud symbol, and you were just supposed to magically guess that, I have to put another router in there to do that. It didn't have sufficient detail as to which serial ports to use it connecting together with. So this lab is more straightforward. It tells you exactly what devices are needed, tells you exactly which pin, which port of which device goes to the other device. And I'm going to do this. I'm going to do it out of order because there's a peculiarity with the network time protocol in that it takes about 3-4 minutes maybe for the network time protocol to sync up between the master devices and the slave devices. So I'm going to go ahead and type those commands in first in the later part of the lab. Then we'll jump back to the first part of the lab and do the Cisco discovery protocol, the link layer discovery protocol. And by the time I get through showing that stuff, we go back and check the show commands in the network time protocol. It should be okay for that. Okay, so I will bring up Packet Tracer. Oh, wait a minute. Why is this not? My mouse action is weird here. Okay, application window, Packet Tracer, share. Oh, I see. I'm not allowed to mute the microphone when I'm in the midst of choosing an application to go in there. Sorry, you got to hear me cough. All right then. So if we looking at the first page of that lab, it says it's the 4000 new 4000 series routers. So I'm going to choose that so that the interface port numbering scheme matches what's in the printed lab. In other words, it has the G001 port 0/0/1 instead of the G00 G01 that's in the 1941 routers that we actually have in there. So I'm going to choose, let's see. I have to go down to the real machine here. I'm going to choose the 4000 series and bring it up. Oh, good, you can see the mouse. So that's going to be an R1. I'll go ahead and take care of that configuration. I'm going to, it'll boot up here much faster than a real router would boot up. Real routers take 3 minutes to boot up. These Packet Tracer routers boot up in just a couple seconds. So this will be our R1, it says on the topology. And I'll make it R1 host name for me. And I'm going to come back a little bit later and do the configuration on that device. I want to get them connected together first. Okay, now we're going to specify a switch. So I'll click on the switch. We'll use a standard 2960 switch. And there are 2 of them. And let's see, am I allowed to make it a little bit bigger here? So they won't. You guys probably got phones or something and they're not real big. Okay, now I'm going to go to the switch 1, and let's make that appear correctly in the diagram as S1. Then I'll go to the switch 2 and make it S2. And let's do the interconnections. So on this particular lab, real straightforward, nothing like that confusing one that I took out of you guys originally doing. I'll click on the lightning bolt connection thing and choose a solid copper straight through cable. And it specifies that the R1 uses the gigabit 001, and that goes to port 5 on the router. And then the second connection will go between the switch 1 and switch 2, both from their number 1 ports, which is, oh, it's appearing on the right part of the screen. It pops off the top here. Okay, so this orange thing on the 2 switch link switch ports want to come up and up by default without a no shutdown command being required. We will have to go back in a little bit and do the no shutdown on the VLAN to make that work. Okay, I guess I'm going to work in reverse order here, and I'm going to go to S2 and configure it first. So I'll click on S2, where we can see the CLI. And you can see the code there that he already did the hostname S2 command automatically for me when I did that GUI tab. And so in the lab, it says that we're going to set the VLAN address, the switch virtual interface, VLAN 1. So I'm going to say interface VLAN 1. Prompt changes the config-if. And this is specified in that chart on the front page of the lab as having an IP address of 10.22.0.3 and a standard /25. And we do have to do a no shutdown on that. Expand this here so we get better screen appearance. Okay, now the other command we're going to do, I'll go back to global config, is we need to establish a default gateway for that switch so they can get back to the router. And so that's going to be the IP default gateway command, and the router port, their friendly neighborhood router port is 10.22.0.1. Okay, that's going to complete the configuration of switch 2 for now. And let's go to switch 1 and set him up. Looks good there on the screen. Go to the CLI tab. And he already did the hostname S1 for me. So on switch 1, I'm going to go into the interface VLAN 1. And this IP address is given on the chart on the front page as 10.22.0.2, 255.255.255.0. The no shutdown on the VLAN. And then let's go back to the configure mode and do that IP default gateway command. And they're both going to go back to their router R1 as their one. Now let's see. Let's do a quick ping test here. I'm on S1. Can I ping 10.22.0.3? Okay. The first couple of dots, the dots is the failure, ping fail. The exclamation mark is the success of the ping. And the first 2 failures were due to the ARP resolution. It was setting up the resolution of the layer 2 MAC address to the layer 3 IP address. So that's working fine. And ARP stays in memory for about 3 minutes, so it's going to work just fine. Okay, now let's go and configure the router. Good visibility on you guys' screens. Let's see. Hold on, I'm gonna check attendance here. See anybody popped in here when anyone looking. So let's see, who's missing? Okay, not here. Who's not here? Okay, I think attendance is up to date. Okay. Here. Okay, I'm going to go to the, am I here? I got to click the seal. Okay. Now we're going to configure the router. And I'll do the Ethernet port first and bring it up and up, because right now that Ethernet port is down, and that's preventing us seeing the any communication between the router and the switches. So he's given us 2 IP addresses there. We'll do the gigabit Ethernet port for us. So I'll say interface gigabit 0/0/1, and his IP address, which is the default gateway for everybody else in the network, is 10.22.0.1. Oh, and of course I forgot to put the IP address. And then let's up the port, activate the port. And now there's a loopback port. Now let's see, we haven't used too many loopback ports before. This is similar to the, when you ping on your desktop PC, the 127.0.0.1 address is a loopback port that's built into the operating system. A loopback port is a useful thing that we can ping. If we run out of the physical ports in the lab, we can simply create loopback addresses. And we're going to use loopback addresses for things later on. Well, we used it, for example, for the, we'll use it for OSPF. We use loopback ports for OSPF and things of that nature to have a stable address that never goes down. Since a loopback port is born up and up, you don't have to do a no shutdown on it. It's a useful reference address that could be like the OSPF identity of our router. Sorry to bring up the OSPF. We haven't covered that yet. There's no objective for that yet. Okay, so I'm at the global configuration mode. I'm going to go interface, loopback, and he says number 1. It's totally arbitrary, doesn't matter what we use. But this is what we do have to put in. So 172.16.1.1, standard 255.255.250.0. Now, it also didn't shutdown. That's a real peculiarity with loopback ports. So if we check, if we do a show IP interface brief and see what's going on here, the loopback port's up and up already. We didn't have to do the no shutdown on it. They're born up and up. Now I can shut it down if I want to. I can do a shutdown on it and then bring it back up again. But he's going to stay up and up just as a reference address for that router. Okay, now let's do a little sanity check. Can we ping our switches? 10.22.0.2 was the first switch. And that's fine, little ARP. And then the other one was the 0.3 address. Okay, so we got good pingability between all the devices in the network. Now, at this point, I'm going to skip ahead to a portion in the lab. I'm going to skip past the CDP stuff, and I'm going to go to it's on page 5 of my lab, where you configure NTP. And we're going to create the Ntp Master on the router. So they got a question that says to show the current time. So show time. Oops. Display the time. Oh dear. The clock, isn't it? There we go. And there's another command, show clock detail, that'll show more information. So we can see the clock is set to a weird date here, 1993. But it doesn't matter what time it's set for. We're just going to use that as a reference time when we do our settings. And he tells us that the time source is the hardware calendar. That's the built-in clock-based calendar, very similar to the clock that's on desktop PCs. Okay, now I'm going to issue the command, and I'm doing this part of the lab first because it can take 3, 4, 5 minutes for this sync to take place between the Ntp Master. We're going to configure this router to be the Ntp Master. It'll be the server, and all the others are going to point back to that address. So let's configure this guy to be the master. I'll go to the configuration mode, Ntp, and tap the help command. We're going to use the command master. We want this machine to act as the Ntp master clock. And at what level is it going to be? And the lab says use level 4, stratum 4. That's all the configuration required on this device. So whatever time this one's set to, all the others are going to use this. This is their master clock. Okay, now let's put this on the side, and let's go to S1 and make him be a client machine. Again, just a quick sanity check. Can I ping the router R1? And it was 10. 10.22.0.1. That's okay. I'm pinging him, so we're good there. Okay. Now let's configure this as an Ntp client. So first of all, let's check the time. Show clock. And it's if I do a show clock detail, this time source is again the hardware calendar. We don't. Eventually, after the NTP syncs up, he's going to say the time source is the NTP server instead of the hardware calendar. But that's going to take several minutes. I'm going to turn these clients on these two switches. Then we'll jump back to the first part of the lab and do the Cisco Discovery Protocol, Link Layer Discovery Protocol. And that should be enough time for these to sync up. We'll go back and check them. Okay, that takes care of S1. I'll minimize him, and I'll bring up S2. Sanity check, can he ping? Can he ping the 10.22.0.1? Yeah, he can. Okay, good. So let's go to the configuration mode and NTP server. It's going to be the 10.22.0.1. Did I forget to do that? That's fun. Hold on. I need to do it on him too. He'll never sync up if I don't tell him to do that. Okay, now let's get back to the earlier part of the lab while we wait for these guys to sync up, because it can take an annoying long. It takes long enough that you think it's not working, even on the real machines. So they've simulated this in the packet tracer to where it looks the same way. Okay, I'm on page 3 of the lab 2. I've skipped the part on page 2 about passwords and things of that nature. I'm going to go straight to the CDP stuff. So he says, first of all, he's instructed on R1. Bring back R1. And we're supposed to type the command show CDP. And he gives us a little reference here as to what's going on. Cisco Discovery Protocol is on by default on all Cisco devices. And they normally send out the information about every 60 seconds. And it takes about 180 seconds for a device. If I lose a connection with another device, after about 3 minutes, then he'll fade away from my report. Okay, the next direction in the lab says we're supposed to issue the command. Before he does that, I'm going to do this traditional command, show CDP neighbors. And the only directed neighbor to R1 is S1. S2 is not a neighbor. He's a hop away on the other side of S1. And so I showed you something similar to this last time when I did the PowerPoint slideshow. This is a great command because it shows you that the S1's G0, R1's G001 port, the local interface on the bottom, next to the bottom line, is connected to a device whose capability is S. It's a switch. As a matter of fact, it's a Cisco 2960 switch under platform. And the wire that's connected to this router's G001 port goes to the fast Ethernet port 0/5 on that switch. So that's great information. And then we can do show CDP neighbors detail and see a whole bunch of information about it. Like, oh, look at it's running the old 12.2 iOS version. Oh, that's the old version. I can't do IP version 6 on that. We would have to upgrade it to version 15.0 or 15.1, which I showed you earlier. You can connect to the packet tracer's built-in server, and it has a TFTP server built into it, and you can actually upgrade the iOS on these devices just as if they were real devices. You can even do password recovery. Okay, now let's go to type the command that he actually says. He types show CDP entry S1. So he's given us a lot of information about this particular device. So we can see what its IP address is. That's useful information for when to ping into it. Shows us the connection ports between this device, the router, and the switches 0/5. Tells us that we're full duplex connection between Ethernet devices. That's a useful little tool for running down half duplex, full duplex mismatches, which can cause a problem. Now here's the gotcha in this lab. Show CDP traffic. Oh, that's an unimplemented command in Packet Tracer. So when you see that part on page 3 of the lab where it says bottom subsection little c, type show CDP traffic, how many packets has it output since the last counter is reset, we can't answer that question. So you don't have to answer that question because it doesn't work in Packet Tracer. Now, if you have the GNS or the ENG with the actual real iOS running on it, this would work. Okay, now what's the next command? He tells you in the lab not to configure the IP addresses till this point, and when you type show CDP entry S1 again, the IP address will not be listed. Remember that for Cisco Discovery Protocol to work, you don't need to configure any IP addresses on any devices. This is why I like to use it as a tool when you first start doing a lab. Just shut down all the physical ports that are connecting your routers and switches together. Give them host names. That's all you've got to do. And then type show CDP neighbors and make sure that the wires are actually plugged into the right device. It's a very common error in the lab because of our confusing patch panels back there that you think you're plugged into R1, you're actually plugged into R2, and you can check to make sure that your physical wiring is okay before you proceed. Okay, the next thing he tells us to do in the lab is to disable CDP globally. So I'm going to go to the configuration mode and say no CDP run. That's going to disable CDP. Okay, now I'm on page 4 of the lab now. I'm the bottom part 3, network discovery with link layer discovery protocol. And so we need to turn that on. Now, link layer discovery protocol is not on by default. So I'm going to type LLDP run and turn it on. Now, let's compare this listing to a show LLDP neighbor. And, oh, it's not running on the other devices as well. Okay, so I need to turn it on all devices. So let me see, I'll do this on R1, and let me do it on S1, LLDP run, and let me do it on S2, LLDP run, LLDP run. They only do what you tell them to, not what you meant them to. Okay, so we're instructed now to go to the S1 console prompt and type the command show LLDP entry S2. We did something similar to this before. Oops, I'm left with the show mode. Show LLDP entry S2. Not implemented in Packet Tracer. What do we got to do here? We could do neighbor. And can we do neighbor detail? Yeah, we can do that. So that's a similar report. Show LLDP entry 2, and let's see, what's the silly question on the lab they ask you here? What is the chassis ID? So in the LLDP one, he has a thing called the chassis ID. And here it is, right here. It's just below the dash lines. Oh, it looks like a MAC address. So the chassis ID for this device in the viewpoint of LLDP is it's the MAC address. In the lab report, they have another address from the machine they wrote the lab with, but this is that one. Okay, so at the middle of page 5, he says console into all devices and use the LLDP commands, and you can use Cisco Discovery Protocol as well. So you could draw the physical network just from show commands. So this is a great, if you go to a company and they don't have good documentation, but at least they know the passwords for their devices and their Cisco devices or any other devices that support LLDP, which is the open standard equivalent of Cisco Discovery Protocol. You can map this out. And this actually happened to me in 1990. I was working for a Cisco reseller in Dallas, Johnson Technical Services, and we went out to a customer, and they didn't have idea how their things were connected together. So I kind of drew a map of their network. You gotta know what's connected to what's else and how things are working properly. If something goes wrong, have you an idea? How can you figure out what's wrong if you don't know what's right? So you need to baseline the thing when you know what's working properly. Okay, I think I can skip that down now to part 4. We configured network time protocol, and let's see what's going on here. Now I'm going to show clock, detail, and look, that was enough time of me jawboning around here. The network time source, it was the battery backup clock. Now it's NTP. Now let's go to S2 and make sure he got it as well. Show clock, detail, and that worked as well. And let's see, a show NTP, a thing here. And it's synchronized. So it shows it's synchronized properly. So let's see, what kind of questions are they asking you here? Just what data time he configures. Okay, so in step 5 of that, use the show command to show the synchronized, show NTP status works, show NTP associations, shows it's working properly. Okay, so there's a little reflection question at the end. It says, within a network, on which interfaces should you not use a discovery protocol, such as Cisco Discovery Protocol or link layer discovery protocol? Just a second here, I'm scanning the attendance. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the only interface that you need it probably within your enterprise, you're probably running Cisco IP phones. They need the Cisco Discovery Protocol. Some other brands of voice over IP telephones use Cisco Discovery Protocol or link layer discovery protocol. They need to figure out what port they're plugged into of the switch so they can know what their phone number is and things of that nature, what group they're in, what department they're in. But you should not use CDP or link layer discovery protocol on that wire, that connection port that leaves your enterprise and goes back to an ISP. That's a public untrusted network. It's okay if, like, South Campus has a connection that goes back to the Trinity River, which is our master server farm and master network center. Yeah, we need that going because we have phones and all the different devices. But for the connection that we have to the internet service provider, CenturyLink, I think we used to use AT&T, now we use CenturyLink. You wouldn't use Cisco Discovery Protocol on that. It would give away too much information. It would be giving away the farm to the bad guys, the malicious intruders, the threat actors. It would be very valuable information for them to know exactly, for example, what version of iOS are we running on that border router that connects to the rest of the world. Maybe they can find a vulnerability to go in and break into that. Okay, let me see now. I'll stop sharing this. And let's see, for the benefit of the people that dropped in later, I'm going to go back and just review quickly here. Oh. Pardon me. Okay, so this is a we've covered today. I covered the 10.8.2 lab. It is a PDF file. If you don't have the ability to edit a PDF file, I don't know if Microsoft Word is able. Kind of tricky. Microsoft Word is kind of clunky. So if you just want to, copy using copy and paste, copy the question and to a Notepad file or WordPad file or Word document and type your answer in there, and you can send that document to me if you don't have the ability to edit PDFs. Monday, this is our last sync session today. Monday will be a work day, and we won't have a skills practical final exam. So we work on catching up on your chapter exams and your labs to turn them in. 50% of your grade will come from your labs. It's about 10 labs, and the 50% of your grade will come from the 10 chapter exams and the final exam, all averaged together equally. Do take this course feedback form sometime before a week from today, because Cisco does have a business rule that you must, it's a business requirement, you must have completed the course feedback form before you can take the final exam. I've also turned on the practice, excuse me, I've also turned on the practice final, and you can use that as a study guide. So the final is scheduled for 9:30 a.m. a week from today, and I'll probably turn it on closer to about 9 o'clock, and you're going to have a whole 24 hours to, well, you only have 1 hour and 45 minutes to take the final, but you can start taking the final anytime within the 24-hour period. And then all work is due, will be due by the next morning at 9 a.m. All work due by Thursday, May the 7th, by 9 in the morning. I'm going to cut off all the exams and close the books, and I got to turn in my grades. Okay, guys, it's been a gas working with you guys this semester, and hopefully by next fall, the courses are available for next fall for the Cisco 3 and 4 course. You can start, I think you can start logging in and signing up for those courses right away. And I think there's a pretty good chance that by the time fall rolls around, all this coronavirus insanity will be over with, and we should be able to come back and actually be in class. Okay, guys, I'm going to put her on mute and hang loose a second in case there's any chat questions, and see you around the bend.